As a result of that, the other rule says the parallel lines must be uniform. Parallel lines must be uniform. By that, they must be of equal length. What I mean by that, when I want to draw this one, let us say I drew this line from here to here, and this line is, let's say it's 8 centimeters. Let us say this line is 8 centimeters. When I want to draw this other one again, in here must be approximately 8 centimeters. This one will not be longer from here to here, and then I draw this one very short here and right. That means those laborings are not uniform. As a result of that, you lose all the marks in that. All the lines must be uniform in length. So if this one from here to here is 8 centimeters, it stops here. The 8 centimeters from here to here can stop around here. Why? They are still of the same length because they are 8 centimeters. But they are not of equal length at this end because this one started in front, so it will be longer this way. And this one continues at the back. So all of them must be of uniform length. If that is the case, we still progress. That the first letter in the labeling must be a capital letter. That means the first letter will be a capital letter. Like if I want to label this one, let us say this particular one here is the mid-read. Mid-read, I will write M-I-D-R-I-D, mid-read, in which the M here becomes a capital letter. If I want to label this one, let us say at the top here, it's apex. I will use capital A-P-E-X. If I want to label this one, let us say the lamina, I will write M-A-L-A-M-I-N-A. The first one becomes a capital letter. The small letters will not be used to start the writing. The other rule says that the first letter will not touch the labeling line. What I mean by that, I am very correct that this part is apex, but I will not label it this way, A-P-E-X, in which the line that I have used to label this diagram touches the A. You will score no marks again for that. So if that is the case, that parallel lines are used that are uniform, the first letter becomes a capital letter, arrows are not used to label that, we now progress. We still progress. The other rule says, when you now want to label again, you draw with pencils and you label with pencil. Have in mind, I said you use the 2H pencils to draw, and the 2H pencil will also be used to label. Don't use a pen to label scientific diagrams. That means they are drawn with pencils and they will be labeled with pencils. Pens will not be used to do that. We go to another phase in the biological diagram. The other phase in the biological diagram is how to represent the magnification of the diagram. Each scientific diagram or biological diagram will now be given by a particular magnification. We call that magnification. What do we call magnification? The magnification is by comparing the diagram you have drawn to the original diagrams. Anytime you compare the diagram you have drawn to the original specimen that you draw, you call that magnification of the organism. That means, let us say I have to draw a particular organism this way. Let us say it is still the leaf. I want to draw this dicot leaf this way. It is possible that the diagram I have drawn, the leaf I have drawn, is larger than the original specimen that I have. It is possible again that the leaf I have drawn is smaller than what I have. Most of the time they present diagrams, you will be given a specimen. The specimen will be in front of you. You now observe that specimen and you draw. So if you are drawing that, what you do is you now present the magnification at the end. That means the magnification is by comparing the diagram you have drawn with the original diagram. How do you do that? In the magnification calculation, you always divide the diagram you have drawn to the original diagram you have. So what I will do here is, I will now measure the length of this diagram. What I have drawn is from here to here. Let us say when I measure the whole diagram here, I'm going to get something like 10 centimeters. That from here to here is 10 centimeters. That is what I have drawn. The one on paper is 10 centimeters. Now what I will do is to take the original leaf, the leaf that was provided to me. I also measure that. Let us say when I measure the original leaf provided, I will get something like, let us say the original diagram, when I measure that, the original leaf, when that is measured, let us say I will get something like 5 centimeters. If that is the case, that tells you that the leaf was very small as compared to the one I have drawn. When I want to get the magnification of this diagram, anytime I want to get the magnification of the diagram, I will use the diagram I have drawn, the length of the diagram drawn divided by the original specimen. Now the diagram I have drawn from here to here, we said is 10 centimeters. I have to divide that by the original specimen. The original specimen is 5 centimeters. I will cancel these centimeters. So if that is the case, the diagram drawn now is 10 divided by the original specimen, that is 5. If I divide 10 by 5, I will get 2. That means the magnification, when you draw the diagram, what you put below that diagram is, you say x2. That means the diagram drawn is 2 times the original one. So when you see x2, that means anytime you see whole numbers, that tells you that the diagram you have drawn is far larger than the original specimen provided. Let us now say the diagram we have drawn is 5 centimeters. Let us take it that way. And the original leaf that was provided was 10 centimeters. So in that case, the magnification will be the diagram drawn is 5 centimeters. Then the original leaf that was given is 10 centimeters. 5 can go here, 1 into there 2 times. That becomes 1/2. So you put x half. That tells you that the original diagram we drew is half of the one provided. So when you see the whole number, anytime you see whole number, the whole number tells you that the diagram drawn is larger than the specimen provided. When you see a fraction, a proper fraction, it tells you that the diagram you have drawn is smaller than the specimen provided. We go to the other rule. The other rule says you always observe the diagrams before you draw. What do you mean by that? What you see on the diagram is what you draw and not what you know. It is possible that you know, for instance, grasshopper. Grasshopper is one of the specimens that each and every one of us are familiar with. Each and every one of us is familiar with grasshopper. And if each and every one of us is familiar with grasshoppers, in the exam you are now given grasshopper to draw. Now somebody might even instruct the examiners will even instruct the invigilators or the teachers that are providing the specimen to remove one of the legs. We already know that grasshopper has 3 pairs of walking legs. That means there are 3 pairs, 6 legs, 3 this way, 3 on the other side. If the examiners now instruct the teachers to remove one of the legs, then you go in the exam and draw 6 legs because you have learned it in books. Before this time, the grasshopper has 3 pairs of walking legs. You draw all the 3 pairs, you get 0 for the diagram. That means what you observe is what you draw, not what you know. It is possible that the diagram, you are very familiar with the diagram, but what is now given to you, some part of that diagram was removed. That is why most of the time you are provided with hand lenses or hand lens to observe the diagram. When you have now observed the diagram, you now find out that there is no part removed. Then you go ahead to draw whatever you have. But if that is not the case, you observe the diagram, whatever that is present on the diagram is what you draw. Now we go to the size of the diagram. Sometimes the size of the diagram will be the most important thing again. Size of the diagram. The size of the diagram will be, most of the time they will say 8 centimeters to 10 centimeters. What do they mean by 8 centimeters to 10 centimeters? That means the diagram you have to draw can either be 8 centimeters, it can be 9 centimeters, it can be 10 centimeters. You don't draw diagram here less than 8. You will not draw diagram above 10 centimeters. So 8 to 10 centimeters means the length of the diagram can either be 8 centimeters, it can be 9 centimeters, it can be 10 centimeters. You don't go beyond that. That is what they mean by that. So the length of that diagram is just by now taking a ruler, you just measure 8 centimeters. What you do now, if you want to do that, you take ruler, you measure 8 centimeters. Let us say if you measure from here to here 8 centimeters, let us say from here to here is 8 centimeters, the whole diagram that you draw will just be within here. So you mark from the 0 centimeter and the 8 centimeter. You put dots here and dots here. It is within that region that you draw the diagram. The labeling will now move out of that, but the diagram itself will just fit in that. Now there are some basic terms again that are used. When you are asked to draw the lateral side of the organism, the lateral side in the exam, if you are asked to draw the lateral view, that means you only draw the side of that organism. The lateral view means the side of that organism. If you are asked to draw the posterior end of that organism, you draw the head part of the organism. If you are asked to draw the anterior part of that organism, or the anterior view of that organism, you draw the tail part of that organism. If you are to draw the dorsal view of the organism, you draw the back of the organism. With that note, I say, God bless you and keep it up.